4 now. We have 2 chapter left, chapter 4 and chapter 5, which is about 14 section. So we should be able to finish it. So let's look at the first section of chapter 4. Is antiderivative and indefinite integral. So I want, instead of write down the theorem and the definition, please read the definition of antiderivative and theorem 4.1 yourself. I will explain the theorem and the definition as we do the example. Alright, so integration is the inverse of differentiation. So it's just the reverse of it. Okay, let's look at my example here. The first one, I have f of x is equal to x to the cube. If I take derivative of this, I will have 3x squared. Alright, look at the second example. I have g of x is equal to x to the cube plus 25. If I take derivative of this, I will have 3x squared. The last one, I have h of x equal to x to the cube minus 3. If I take derivative of this, I will have 3x squared. Alright, so the reverse of this, if I take an integral of this, I should get this back. Alright, or if I take an integral of this, I should get this back. So basically, I take an integral of 3x squared. I should have x to the cube back. But I also have constant because derivative of constant is 0. That's why it doesn't show here. So think of this as plus 0. Alright, this is plus 25 and minus 3. So I'm going to use capital C. Alright, plus C. So that's the notation. If you take an integral of f prime of x dx, you should get f of x plus c. C here is referred to constant. Make sure you don't forget the c. So the first rule, basically if you take an integral of variable raised to some power, any power, dx, you're going to add 1 to the power and divide by n plus 1. Think about this one. Alright, think about this one is I apply that formula. I have an integral of 3x squared. Alright, I'm going to have 3x. I have 2 here. I'm going to plus 1 to it. So I'm going to have 2 plus 1 over 2 plus 1 as the formula mentioned. So I'm going to have 3x to the cube over 3, which is, the 3 can cancel, which is x to the cube, plus c. Alright, you have to plus c. So let's look at the first example here. Alright, I have an integral of 8x to the cube minus 9x squared plus 4x dx. This is 3 terms. Alright, I'm going to take it, I allowed to take an integral on each term. So I'm going to have an integral of 8x to the cube dx minus an integral 9x squared dx plus an integral of 4x dx. Alright, I take an integral of each term that allow. Next step, there is a theorem said I can bring out the constant. I can take out the constant, so I'm going to take out the 8. So I have 8x to the cube dx minus 9, an integral of x squared dx plus 4, an integral of x dx. Alright? So I just, at this point, I just take out the constant. Now I'm going to apply this rule here because I have variable to the exponential, x to the cube, x to the square, and this is x to the first. I can apply this formula here. Okay. The first term, I'm going to have 8 times x to the third plus 1 over 3 plus 1. Apply that formula there. minus 9. The second term I'm going to have x squared plus 1 over x squared plus 1 over 2 plus 1. And the last term, this is just the first power, so I'm going to have x 1 plus 1 over 1 plus 1, and don't forget the capital C. Alright, so I'm going to simplify a little bit. I'm going to have 8 times x to the 4th over 4 minus 9 x to the cube over 3 plus 4 times x squared over 2 plus c. Alright, and I can reduce this, alright, so because they are multiplied. So 4 can go to 8 2 times, 3 can go to 9 3 times, and 2 can go to 4 2 times. Alright, so my final answer is going to be 2x to the 4th minus 3x to the cube plus 2x squared plus c. And now if you want to check your answer, you take derivative of this. 4 times 2 is 8, x to the cube. 3 times 3 is 9. The power reduced by 1, so 9x squared. 2 times 2 is 4, x to the first. Right? Hi, let's look at our next example. I have an integral of square root of x plus 1 over 2 square root of x, quantity dx. I'm going to apply the first rule, which means I allow to take an integral of each term individually. So I'm going to have an integral of square root of x dx plus an integral of 1 over 2 square root of x dx. Alright, and from here, it doesn't fit our formula. You see, our formula, I have variable raised to some exponential power. In the intermediate algebra, you may remember that I can rewrite the radical as an exponential. So I'm going to do that here. So I'm going to have an integral of x to the 1/2 dx. Because square root of x is the same thing as x to the 1/2. And for the second term, I'm going to bring out the 1/2 because it's constant. So I'm going to bring out the 1/2. However, this one is x to the 1/2. If I bring it to the numerator, I'm going to have x to the negative 1/2 dx. Because this is x to the 1/2, I bring it up. Alright, now I can apply the formula because I have a variable raised to some exponential. So the first one is going to be x to the 1/2 plus 1. I'm going to write it as 2 over 2. Right? So divide by 1/2 plus 2 over 2 plus c. Let's call it c1. Alright, some constant. We don't know what it is. Let's call it c1. The second term, I'm going to have 1/2 and then x to the negative half plus 1. I'm going to write it as plus 2 over 2 divided by negative 1/2 plus 1, which is 2 over 2 plus, let's call it c2. It's a constant. We don't know what it is. So let's simplify this a little bit. I'm going to have x to the 3/2 over 3/2. Alright, I have c1 and c2 here. It's a constant. Any constant, you can add them, you can subtract them. I'm going to call it capital C for now. So I'm going to have the second term, I'm going to have 1/2 x to the 1/2 over 1/2. Again, c1 and c2 can combine. I call it capital C. Alright, so let's simplify a little bit. I will reciprocal this. So I'm going to have 2 over 3 x to the 3/2. The 1/2 and 1/2 reduce. So I'm going to have plus x to the 1/2 plus c, which is constant. We don't know what it is. For now, we call it capital C. If you want to check your answer, you can take the derivative of this, and you should get your original function back. Alright, let's look at the next one. Hi, let's go to our next example. Let's review some derivative first. If you remember from the previous chapter, derivative of psi is cosine. Obviously, if you take an integral of cosine of x dx, you're going to have sine of x plus c. Alright? Also, derivative of secant of x is equal to secant of x tangent of x. So if you take an integral of secant of x tangent of x dx, you should have secant of x plus c. Now let's look at our example 4. This is a trig function, and I have an integral of sine of x over 1 minus sine square of x dx. So I'm going to rewrite this, alright? I'm going to have an integral of sine of x over 1 minus sine square of x is cosine square of x dx, alright, from trig. Now I'm going to rewrite it again. I have cosine square of x. I'm going to write it as 1 over cosine of x times sine of x over cosine of x dx. Alright, I'm split the cosine square of x into two terms. Now the first term is just secant of x times the second term sine of x, cosine of x is just tangent of x dx. And as I mentioned earlier, an integral of secant of x tangent of x is just secant of x plus c. So this is secant of x plus c. Let's look at the next one. They want you to solve for the differential equation. So they want you to find f of x. They're giving f prime of x is equal to 6x and f of 0 equal to 8. So I'm going to start from f prime of x. So I'm going to take an integral of 6x dx. So I can take the 6 out. Then I would have x square over 2, I skip step a little bit here, alright, plus c, alright. I'm using the formula over here. So now I can reduce 2 could go into 6 3 times, so 3x squared plus c. This is equal to my f of x function. However, I have a constant c here that we don't know what it is. We have to figure out what is the c. So what I'm going to do, I'm going to use f of 0 equal to 8, alright? This is mean if x is 0, the y or the f of 0 equal to 8. So I'm going to put 8 here. 3, my x is 0, so 0 square plus c. Obviously the first term go to 0, so my c is just 8. So my function f of x is equal to 3x squared plus 8. Again, if you take the derivative of this, you should get 6x, which we did. Alright, we finished 4.1. See you next time. Bye.